to another explainer. Today, we're taking a journey to the absolute edge of reality. We're going to use some hard cosmic data to conceptualize a location so far away, well, the numbers honestly kind of lose their meaning. But by breaking it down, we can make perfect sense of the absolute limits of the known universe. This is an exploration of our cosmic boundaries, a real chance to peer back to the dawn of time itself and understand exactly what is out there in the deepest reaches of the dark. Okay, so let's start with a really fundamental question. What is the most distant place? You know, it's just human nature to want to find the edge of the map, right? Throughout history, we've always looked to the horizon and asked, what's the absolute furthest point out there? But when we ask this question about the cosmos today, we aren't just talking about regular geography or spatial distance anymore. We are talking about stretching our most advanced technology to its literal breaking point just to capture a tiny, incredibly faint signal from the absolute deepest abyss of space. And that ultimate destination actually has a name. It's JADES-GS-z14. Now I know, that definitely doesn't roll off the tongue like Mars or Andromeda, but this specific catalog designation represents the absolute limit of human observation right now. Discovered by the James Webb Space Telescope, this wasn't some giant glowing orb filling the lens. No, it was a barely visible point of light. And what's super fascinating here is that because the universe is expanding, the light from this galaxy was stretched, or redshifted, so severely over billions of years that it entirely dropped out of the visible light spectrum. We could literally only detect it as a few precious pixels of infrared data. But upon closer inspection, those specific pixels turned out to be the most distant confirmed location in the observable universe. And that brings us to this staggering number, over 13 billion years. This represents exactly how long the light from this galaxy has been traveling across the cosmos just to reach our telescope. Honestly, it's incredibly difficult for the human brain to process a number that large, so let's try to ground it a bit. To put that into perspective, 1,000,000 seconds is about 11 days, right? 1,000,000,000 seconds is over 31 years. This light has been traveling for 13 billion years. Talk about the ultimate cosmic commute. It's not just a measure of mind-boggling distance, it's a measure of unparalleled endurance. Just think about the sheer resilience of those photons, flying through the freezing, expanding vacuum of space, bypassing nebulas and black holes without hitting a single thing for 13 eons, until they finally collided with the golden, beryllium mirrors of the James Webb Space Telescope. Right, and this journey brilliantly illustrates the sheer scale we're dealing with. The light began its journey over 13 billion years ago, which means this light was already well on its way before the Earth even existed. It didn't just start its journey a long time ago, it was already racing through the void before our sun or our entire solar system were even a thought in the cosmic cloud. For roughly 8.5 billion years, this light was just flying through the utter dark of an expanding universe. And then gravity started pulling dust and gas together in our little corner of the Milky Way to form our Earth. You know, dinosaurs came and went, humans evolved, we built entire civilizations, we finally launched a super cool telescope 1,000,000 miles into space, and only then did that ancient light finally arrive to tell its story. Wild, right? Let's move on to this next number, 290 million years, because this immense distance fundamentally reshapes our understanding of the universe's infancy. This number represents the actual age of the entire universe when that specific light was emitted. While hundreds of millions of years sounds like a super long time to us, in cosmic terms, it is literally the blink of an eye. The universe today is estimated to be about 13.8 billion years old. So, when JADES-GS-z14-0 released the light that we are just now seeing, the universe was only at about 2% of its current age. The cosmic dark ages had just barely ended. We are looking at a universe that had essentially just woken up, where the very first generations of stars, these massive, blazing hot, entirely metal-free giants, were just starting to pierce through the primordial hydrogen fog and light up the dark. And that leads perfectly into this thought, the very earliest stages of everything. This is exactly why this discovery matters so much. We aren't just looking at an old rock or a dying star here. We are getting a literal front row seat to the dawn of creation. By analyzing this faint point of light, astrophysicists can figure out the exact ingredients of the early universe. We could actually start answering massive questions like, how did galaxies form so rapidly after the Big Bang? What was the exact chemical makeup of the cosmos right after the lights turned on? This single, incredibly distant galaxy is basically a pristine laboratory holding the secrets to the foundational moments of our reality. It's giving us the very first chapters of a 13.8 billion-year-old history book.
So what does it actually mean to look into the past? This sets up the ultimate puzzle we need to solve: how distance in space literally equals time travel. We've already established that the light took over 13 billion years to get here, but it's fascinating to remember what that physically means for us as observers. Because light has a universal speed limit, we are always looking into the past, no matter what we look at. Just as we see our own sun as it was 8 minutes ago, looking at the extreme edge of the known universe means we have built a literal, functioning time machine. We don't see the universe as it is simultaneously right now. We see a layered cross-section of cosmic history. The deeper we look into the dark, the further back in time we see.
To truly grasp this, let's step through this timeline to really ground our understanding of these cosmic timescales. Step 1. Light leaves the early galaxy. It begins with JADES-GS-z14 shining fiercely in the infant universe, a chaotic burst of star formation sending its light on a one-way trip outward. Step 2. Billions of years pass, and Earth finally forms. We have this unimaginably long silence, billions upon billions of years of empty travel while the universe expands around it. Massive cosmic structures form, our Milky Way churns and takes shape, and our planet finally cools into a habitable world. And then step 3. JWST captures the ancient light today. The climax of this epic journey is happening right now in our modern era, as humanity's most advanced engineering marvel acts basically like a giant catcher's mitt to finally receive this ancient message from the dawn of time.
Now this brings us to a really great cosmic paradox. On one hand, think about the image we actually see. A galaxy exactly as it was 13 billion years ago. We possess hard data showing a baby galaxy, glowing with the fierce ultraviolet energy of new stars. That is our concrete observation. But then contrast that with the reality right now, a place that probably looks completely different today. The reality out there at this exact second is that this place has had over 13 billion years to grow up. It's likely collided and merged with other galaxies, formed supermassive black holes at its center, and bred hundreds of generations of new star systems packed with heavy elements. So the image we see is entirely real, but the place it depicts is practically a ghost, long gone, replaced by an evolved, modern galaxy that we currently cannot see.
And I'll leave you with this final, mind-boggling thought to ponder. It exists right now, but remains forever out of reach. We know this place is out there, evolving at this exact second. Yet because of the universal speed limit of light and the accelerating expansion of the universe, its current reality is something we will never, ever be able to see. The space between us is stretching so fast that the light leaving that evolved galaxy today is literally fighting a losing battle against the expanding fabric of space itself. We share the exact same present moment with this distant place, yet we are separated by a permanent, unbreakable cosmic veil. So if this is what we find at the extreme edge of our current vision, what profound mysteries do you think are waiting just beyond the threshold of the unobservable universe? Thank you for joining me on this explainer, and as always, keep looking up.